Hi, I'm Dave Jones with Storm Center Communications and GeoCollaborate. I'm going to be taking a deeper dive into visualization of the weather phenomenon known as El Nino and La Nina. This is a map of sea surface temperatures around the globe. As you can see, the ocean temperature is not uniformly distributed. The equator receives more solar radiation per unit area than the poles. Therefore, the tropical oceans are warmer than other parts of the world. The surface water in the western Pacific off the coast of Asia are often warmer than the eastern Pacific. In addition to solar radiation, winds, currents, and clouds can also change the temperature pattern. Let's isolate the Pacific Ocean and look at the changes below the surface. At the equator, below the surface, there is a sharp change in temperature that separates the warmer surface water from the deep, cool water. This is known as the thermocline and is typically identified by the depth of the 20 degrees C isotherm. Typically in the East Pacific, the cold water is close to the surface, and in the West, the accumulated warm water pushes down the thermocline. Every 2 to 7 years, the warm pool of water spreads eastward into a long, shallow pool, flattening the tilt of the thermocline. This phenomenon is called El Nino. El Nino is one of the two phases of the larger phenomenon called El Nino Southern Oscillation, or ENSO. The other phase of ENSO is La Nina. El Nino is the warm phase, and La Nina is the cool phase. From November 2021 to December 2023, we had a unique opportunity to observe the transition from La Nina to El Nino. ENSO has important consequences for weather around the globe, such as changing flood and drought patterns. To make the changes in the temperature easier to see, let's show the temperature deviation from normal conditions instead of the absolute temperature. One indicator for El Nino is an index defined by sea surface temperature deviation from normal in a particular region in the Pacific. This region in the Central Pacific is called Nino 3.4 region. During La Nina, we see a cold tongue by the East Central Pacific. As El Nino develops in 2023, we see a warm tongue extending across the Central Pacific. As we transition from La Nina to El Nino, the Nino 3.4 index changes from negative to positive values. We can also look at the sea surface temperature, or SST, on the globe, where the surface water is exaggerated by the sea surface height. Deviation from the normal conditions are shown. Colder sea surface temperatures produce dips, and warmer sea surface temperatures create bulges in the sea surface. So during La Nina, the sea surface level is generally lower than normal, and conversely, higher than normal during El Nino. During El Nino, these changes in the sea surface temperature and the sea level are mostly driven by the changes in the winds on the surface of the ocean. In order to see these changes better, let's look beneath the surface again. We highly exaggerate the sea surface height changes to be able to see the centimeters of changes across the Pacific. The subsurface also shows warm anomalies in red, moving eastward as the surface water moves away from the eastern Pacific. The cool deep water moves upward along the coast of South America. We can also see that the temperature anomalies move along the thermocline as it's flattened by the El Nino development. The temperature contrast along the Pacific is linked to the atmospheric circulation right above the ocean, known as the Walker circulation. The Walker circulation is driven by the atmospheric convection over warm waters, that's thunderstorm activity. The circulation spans 10,000 miles across the Pacific Ocean along the equator. It extends vertically between the Earth's surface and the tropopause, and horizontally from South America's westward coast to Australia and Indonesia. The Walker cell is visualized with wind vector anomalies represented by streamlines. The arrows are colored by the vertical velocity, upward is red, downward is blue. The bigger the arrowheads, the stronger the winds upward or downward. During La Nina, the warm waters in the West Pacific add extra heat to the air, resulting in rising motion where there are more clouds and rainfall. Starting March 2023, this cycle breaks down. The surface trade winds weaken the warm water anomalies spread eastward, and therefore the convective rising branch of the Walker circulation shifts to the Central and East Pacific. ENSO affects the global weather by altering the rainfall pattern. During La Nina, Indonesia and the maritime continent become wetter than normal. During El Nino, it becomes drier than normal. In the equatorial East Africa, conditions are drier than normal during La Nina and wetter than normal during El Nino. In northern Brazil, La Nina brings wetter than normal conditions, while El Nino brings drier than normal conditions. The opposite occurs in southern Brazil and Uruguay. Central America, northern Peru, and Ecuador all experience heavy rainfall during this El Nino. During La Nina, there is more upwelling of cold water off the coast of Peru. Therefore, there's a higher biological productivity, leading to a higher population of zooplankton, which attracts fish schooling. This is reduced during El Nino. Observing and studying these ENSO events can be used as a source to make better predictions of the climate system.